Hello everyone, welcome to the channel DEVOPS Tech Stack. Today we are going to learn day 12 of the Devops Bootcamp series. Before starting today's video, let's quickly recap what we have learned so far. We understood what is software development lifecycle and what's agile method. Why we moved from the waterfall model to the DevOps approach. Then we discussed all about planning stage in software development lifecycle that includes the Jira software. Then I shared with you all the quick overview on the DevOps roles and responsibilities. Not only that, we discussed from the very basics that what is the operating system, what is hypervisor, what are the virtual machines, and then created our first EC2 instance on the AWS cloud for doing all the labs so that we all will be on the same page while performing any practicals. Also, we discussed why Linux is most popular in the DevOps world and learned how to install software using the package manager tool in Linux. At last, not the least, we discussed about Linux file management and the most important Linux commands used almost daily by the DevOps engineers. In today's video, we are going to discuss about the input-output redirection and the piping in Linux. So without any further delay, let's quickly get started. When you run any command on the Linux system, it takes some input from your terminal and gives an output back to the terminal. Basically, it runs instructions given from the command line interface using the switches to create the output back to the terminal. The standard input device is usually the keyboard and the standard output device is the screen. Let's try to hit some command in the terminal. Again, for the lab, I have created one EC2 instance on the AWS cloud. As I have already shown in my previous video, you can create one instance on the AWS and connect to that particular machine using the SSH. If I type some command over here, so the input is my keyboard. Using that, I am typing some command over the terminal. So output you are seeing over the terminal, that is the standard output you are seeing. That is being displayed on the screen. Fine. Now, what is the need of input-output redirection? Let us understand this by taking a scenario. Let us assume we want to run cal, that is for the calendar command. It will print the output to the current terminal screen as I have already shown you. But if we want to save this output to some file, and instead of printing out on the screen, we would need a way to redirect the command output to the desired file. How to do it? The same way, if we run some command, let's say head, or let's say if you want to do ls over a particular directory, it needs an input to produce the output. So we can either write our input in the form of a command directly or provide or redirect input from any other place or the file. Now, whenever you run any command or program on the Linux system, it has three streams opened. The first one is the standard input, the second one is the standard output, and to print the debug message or the error message that are represented by the standard error. Now, let us understand them one by one. First, we will discuss about the standard input redirection. The standard input redirection, also represented by the less than symbol, streams takes the data or input from a user or a program. Those programs receives input from a device, for example, keyboard. In Linux, we can pass the standard inputs from the files are also allowed. For example, if you want to see the content of some file, then you are using cat etc resolve.conf. Like if you want to see the content of this particular file, you can pass this command over the terminal and you will get the result. Okay. Now the same command, if we want to pass as the standard input, so we can write less than symbol over here and it will treat this particular file as the input to the cat command and it will display you the output. So it is the same thing. So using the less than symbol, you are seeing the use of the standard input. In this case, we are not passing the input from the keyboard. Instead, we are passing the input from a particular file, and using the less symbol, we are passing the standard input redirection over here, and this particular output is shown over the terminal. In Linux, the file descriptor 0 is associated with standard in. How to try that? Here, if you write 0, it is also denoting the standard input, and you will get the same result. A standard input will be terminated once it reaches the end of the file. End of file means that there is no further data to be read. Like for this example, only these are the content and this is the end of the file. After that, it will not read anything. Let us now understand one more example where we are counting the number of lines in a particular file. For that case, I will write wc-l. -l is for the number of line count. After that, less than symbol and then the same file name we will pass over here. Okay, and let's hit enter. Here you will get the result number of lines. Only 4 lines are there, so it will print you 4. So what is happening? WC knows that the input is coming from the standard input, that is in the form of file. So it will display you the correct result over here. Now let's talk about the standard output redirection. The standard output typically goes to the console. The standard output streams, when not redirected, will output the text to the screen or terminal. Let's, for example, if I type cal, then it will show you the calendar over the screen or over the terminal. Also, for example, the echo command displays any input argument passed to it on the command line. Let's type echo and then DEVOPS-TECHSTACK over here. You will get the result, that is DEVOPS-TECHSTACK. Now to redirect standard out on a Linux to file, you have to use the greater than symbol. For a standard input, we have passed the less than symbol. For a standard output, you need to pass greater than symbol, greater than abc.txt. Means the output of this particular command will be redirected or saved into a file, that is abc.txt. Let's hit enter. Now if you do ls over here, you will see that one file is created, that is abc.txt. If you cat abc.txt, you will see the same result what we have seen here. Okay. So what is happening here? This redirect the output to the file, not to the terminal. Let's clear the screen. And now talk about the third one, redirection operator, that is standard error. There are two ways a command could produce its output. It could either a valid output or it could be an error message. But both of them will be by default get delivered to the same place as a standard output, that is your terminal screen. For example, if you run a wrong command or with bad parameters, you will see an error message on your screen, and that it has been some error is there and it could not be processed, or this command could not be processed. So in that case, you can pass those error message to some file. For example, in Linux, we have a special file inside the /dev/null file. So those error message you can pass over that particular file. How to do that? For example, you are writing ls-l tb.txt, but there is no file name as tb.txt in your current directory. So you will get message or error like cannot access tb.txt, no such file or directory. So in that case, you can redirect this particular output or this particular error message onto a simple file. For example, I am storing this error message onto a file named as error.txt. Now do ls over here, you will see this file is generated, and cat over this file, you will see that same message. See, cannot access tb.txt, no such file or directory. So again, 2 is the file descriptor that is being used for the standard error message. As I have previously also told, like 0 file descriptor is associated with the standard input, then 2 is associated with the standard error. Now let's discuss about the type of redirection operations. We have learnt about the redirection commands for each stream. When we do redirection to a file, either the file will be overwritten or the content will get appended to it. So basically, when you use one greater than symbol, that sign, then the output file will always get overwritten with the new content. And if you use double greater than sign, then it will append that particular content. Okay, let's try that. If you try this particular command only, but in place of tb.txt, we will write tb1.txt. Okay, now the message will be changed, and since you are using the only one greater than symbol, the content will be overwritten. How content is overwritten? Now previously, as you have seen that this was the message, but now this time you are seeing this particular message. But if you don't want the content to be overwritten and you want to append the new content over the same file, then in that case you need to use double symbol. Let's try that. Okay. Now in place of tb1, we will give tb2. Let's hit enter. Now cat over this particular file, you will see both the contents are there. Sorry, again we have passed only one greater than symbol. We need to pass 2 greater than. Okay, fine. Now cat this particular file, and you will see the new content is overridden in the same file. So this is the main difference between 1 greater than symbol and 2 greater than symbol. Both are used for the standard output redirection, but what is the basic difference? In double greater than symbol, the content will be appended, but in case of single greater than symbol, the content will be overwritten. Now let's try one more thing. That is, we will try standard input and standard output simultaneously. What I meant to say, let's try cat over this particular file. Okay. Now here, if you want to use a standard input on this particular file, then how to write? Cat less than symbol and then error.txt. What is this? Cat is taking this particular file as the input and it will display the output in the terminal. But we don't want to display the output in the terminal. Instead, we want to redirect the output to error1.txt. What will happen? Whatever the content is existing inside this particular file, it will be copied onto the error1.txt. So it is similar to what we do using the cp command. And in short, we are using a standard input and a standard output together. Now let's try cat over error1.txt. You will see that this content and this content is both same because we are just copying these files using the standard input and output simultaneously. The last thing what we are going to discuss is the pipes in Linux. The pipe command denoted by the symbol, this one. Okay. So it basically allows you to send output of one command to another command for further processing. It can redirect the standard output, input or any error of one process to the another. How to try that? Like if you write command 1 and then pipeline, then command 2, then again pipe, then command 3. What is basically happening here? Output of this command is being treated as the input to this command and it will be further processed. Again, the output of this one will be sent to the input to this one and it will be further processed. Okay. Now let us understand this with an example. There is a file named as etc/fs/tab. Okay. Now we want to count the number of lines in this particular file. To display the content of the file, we will use the cat command, and to count the number of word or line in this particular file, you need to use the wc command. So the output of this particular command will be treated as the input to wc-l. Means to the word count, we will treat this particular output as the input. So let's hit enter. You will see 2. Means 2 number of lines are there present in this particular file. This is the basic use of the pipe command in Linux and it is very useful concept. Also, let's try one more scenario. If you do ls over here, you will see these many content over this particular directory. But you just want to see error1.txt. So here also we can use the pipe concept. Do ls and then output of this particular command will be treated as input to the next command, that is grep, and then I will write 1.txt. Fine. Then if you hit enter, you will see only this particular content is being displayed because the filter 1.txt is only present over this particular file. So grep is used for the filter, as we have already discussed in the last lecture. What we are doing? We are first doing ls. With ls you are seeing these many contents. After that we are passing that particular output to the input to this particular command, that is the right side, and we are filtering just 1.txt. Whatever the files which are having 1.txt in their name, we are just filtering that particular file and you will see the result. That's all for this detailed video which covered different aspects of handling file descriptor streams and the redirection on the Linux system. Thank you all for your immense support. I hope you are liking our videos. Please do like, share, comment and subscribe for more such videos. Thank you again.